Hey friends, have you ever wondered how big ships and airplanes find their way in the dark night or thick fog? They don't have magic eyes, right? They use a super cool technology called radar. Radar is something that helps us see things our eyes can't. It's like a superpower, but it's science, friends, pure science. It was invented during the Second World War. Scientists needed a way to spot enemy planes from far away, whether it was day or night. That's where the story of radar began. So what does this word radar mean? It's not some strange name. It has a complete meaning. Radar stands for radio detection and ranging. Let's make it a bit simpler. Radio means using radio waves. Detection means finding something like a detective finds a crime, and ranging means measuring the distance to that thing. So the full meaning is using radio waves to find something and measure its distance. See how simple it is? This name itself tells the whole secret of how it works. Imagine you're standing in a dark room and you have a flashlight in your hand. You want to know where the wall is. What will you do? You'll turn on the flashlight. The light will go, hit the wall, and come back to your eyes, and you'll know the wall is in front of you. Radar works exactly the same way, but instead of light, it uses radio waves, which we can't see. These waves travel at the speed of light, which is very, very fast. That's why radar can detect distant objects in the blink of an eye. This technology is so amazing that it has changed our world. In the Second World War, it helped keep countries safe, and today it's part of our daily lives. From cars to weather forecasts, radar's magic is everywhere. It's a great example of how a need gives birth to a new invention, and that invention then benefits all of humanity. So let's move on and see how this magical system actually works. Science rules. So, now the most important question, how does radar work? The science behind it is very interesting. A radar system has two main parts, a transmitter and a receiver. The transmitter's job is to send out radio waves loudly. It's just like shouting. Imagine you're standing in front of a mountain and you shout hello loudly. Your voice goes, hits the mountain, and after some time comes back to you, which we call an echo. A radar's transmitter also sends out a shout of radio waves, just like that. When these radio waves travel in the air, they spread out in all directions. If something comes in their path, like an airplane, a storm, or another ship, these waves hit that object and bounce back. It's just like your hello voice bouncing back from the mountain. The second part of the radar system, the receiver, acts like a big ear. Its job is just to wait for those bounce-back echo waves to reach it. As soon as the receiver gets this echo, it immediately tells the computer. Now the real magic begins. The computer is very smart. It calculates two things. First, how much time it took for the radio waves to go and come back. Since we know that radio waves travel at the speed of light, the computer can easily tell how far away that object is by calculating this time. If the echo came back quickly, it means the object is close. If it came back late, the object is far away. This process is called ranging, as we saw in the name. Super simple, right? The second thing the computer figures out is the direction of the object. The radar antenna keeps rotating, and it notes from which direction the echo is coming back. If the antenna sent waves towards the east, and the echo also came back from there, the computer knows the object is in the east. When all this information, distance and direction comes together, the computer displays it on a screen. A small dot or mark appears on the screen, which is called a blip. That's how radar sees everything, even in the dark. Let's take a real-world example now, a busy airport. At an airport, there's air traffic control, ATC, whose job is to safely land and take off all airplanes. They have a very powerful radar system. The airport's big rotating antenna constantly sends out radio waves. When these waves hit an airplane flying in the sky, they come back to the ATC's receiver. The computer immediately processes this information and shows a small blip on its screen. This blip isn't just a dot, it contains a lot of information. The ATC controller sees on the screen how far away the airplane is, how high it is, and in which direction it's going. They can also see the airplane's speed. This gives them a clear map of the entire sky. They can keep an eye on dozens of planes at the same time. If two planes are getting too close to each other, the radar alerts them beforehand, allowing the controller to send them on different paths and prevent a collision. Without radar, managing so many planes would be impossible. Now let's leave the airport and head towards the sea. Large cargo ships and cruise liners travel even in thick fog or stormy weather. For them, radar is a lifesaver. The radar on top of the ship keeps rotating and sending out radio waves. These waves tell them if there's another ship nearby. Besides that, they can also see the shoreline, rocks, or icebergs. If the Titanic had modern radar at that time, they would have seen that iceberg from afar, and perhaps such a big disaster wouldn't have happened. But radar's job isn't limited to ships. It's also a hero in telling us about the weather. The meteorological department uses Doppler radar. This radar can detect raindrops, snow, and hail in the air. It can tell us which way a storm is moving, its speed, and how dangerous it might be. When you see on TV that heavy rain is expected in the next few hours, this information often comes from radar. This allows people to be warned in advance about disasters like storms, cyclones, and floods. So now you must have understood that radar is not just a strange rotating dish, but it's a very big protector of our safety. Its biggest job is to prevent accidents. Whether it's a collision between two airplanes in the sky or two ships at sea, radar acts like an invisible guard. It's the third eye of pilots and ship captains, showing them dangers they can't see with their own eyes. It gives them the necessary time to make the right decision, keeping millions of lives safe every year. Imagine how different our world would be without it. So many flights wouldn't be able to operate at airports at the same time. Reaching our destination would become difficult and take longer. Sea trade would become very risky, making it difficult for goods to reach us. Weather warnings wouldn't be available on time, leading to more loss of life and property in storms and floods. Radar has made our way of traveling and living safer and easier. It's a technology that quietly does its job behind the scenes. The use of radar doesn't stop here. The police also use speed guns to catch speeding cars, which is a small radar. Scientists use it to map the Earth and other planets. Even some new cars have radar for adaptive cruise control, which maintains a safe distance from the car in front. This means radar has now become a part of our daily lives, enhancing our safety at every step. In the end, radar is the biggest proof of how science can make our lives better. A simple idea, using echoes to detect things, is running the whole world today. It shows us the way in the dark, saves us from storms, and makes our journeys safe. So next time you see an airplane in the sky or hear a weather report, remember that invisible magic called radar. It's science, friends, and it's very cool.